In this video, I'll be covering how to make sulfuric acid using oxalic acid, H2C2O4. Some information. This is not a historical reaction. It's really found only in modern times, I would say in the last 5 to 10 years. It cannot be traced back to any single person or a lab. In regards to sulfuric acid, it's been around a long time. It's known as old, and originally it was known as oil of vitriol. In this particular experiment, we're going to be using oxalic acid dihydrate, ferrous sulfate heptahydrate, and ascorbic acid as a reducer, and I'll go into this more in detail later. Typically, when you're mixing a strong acid salt, which in this case would be the ferrous sulfate, of course, it's a powder, but it's known as a strong acid salt, and a weak acid, which is oxalic acid, I even covered that in a previous video, there is no reaction between the two. This experiment only works due to the fact that one of the products is quite insoluble. To help understand this better, I'm going to go over the reaction a little earlier than I usually do. So here's our iron sulfate plus our oxalic acid gives you iron 2 oxalate and sulfuric acid. Obviously, I left the waters off of here, but they're not important for this. So as the iron oxalate is insoluble, this portion right here, iron 2 oxalate, as it falls out of solution, it drags the reaction to the right, and it makes this reaction possible. So you can just imagine as this is forming and one of the products is actually dropping out of solution and not reacting anymore, it's going to just pull this to the right. You kind of have to use your imagination. But there is a problem that happens in this reaction also. And the primary problem with this reaction is the iron 2 oxalate, that right there, can become iron 3 oxalate. And this is quite soluble. And so the reaction becomes reversible and it decreases your sulfuric acid yield. So if this becomes iron 3 oxalate in the reaction, which can happen, it's no longer falling out of solution, it's staying soluble, and therefore this is not getting dragged to the right, so you don't get as much sulfuric acid. So what we need to do is add a reducing agent. I mentioned this earlier when I was talking about ascorbic acid. So yep, I'm using ascorbic acid C6H8O6. So the overall reaction, including the ascorbic acid, is the iron sulfate plus oxalic acid plus the ascorbic acid gives us the iron 2 oxalate mostly, with the ascorbic acid plus sulfuric acid plus dihydroascorbic acid, which is C6H6O6. So that's left in solution, and water. Dihydroascorbic acid, here written as DHA, does not interfere at all with this reaction at any point. In our materials, so we need our iron sulfate heptahydrate, 300 grams. We're going to dissolve that in 1 liter. We need our oxalic acid dihydrate, 200 grams dissolved in 400 milliliters of water. And we need our ascorbic acid, 105 grams dissolved in as little water as possible. Our methods, we're going to change things up just a bit. So number 1, here is dissolve 2 and 3 in their respective amounts of water as necessary. So these are both done and set aside. Then number 2 is dissolve number 1 in its water, and I'm going to do that in a 2-liter beaker because the next step is to mix 2 and 3 to 1 in that order. So we're going to first add the oxalic acid solution to the iron sulfate solution, and then we're going to add the ascorbic acid to these two solutions, which have already been mixed. And when we do that, we're already forming our sulfuric acid. We want these to mix well for a bit so everything has a chance to interact. And because the iron 2 oxalate is insoluble, we'll filter that out. So we just have the filtrate at this point. We're then going to boil down the filtrate to approximately 20 to 25% of its total value. So we'll end up with around 4 to 5, maybe 600 milliliters, depending on how much we start with. But we're starting with around 1.6 to 1.8 liters. So like 1800 milliliters. And if you multiply that by 0.25, I think you get around 450 milliliters. So point is, we're going to get rid of a lot of the water because we used a lot of water to start with. So we're going to get rid of as much as we can here. This will be interesting because when we boil this down, we're going to use quite a bit of heat. And when you use that much heat with the number of items in the reaction here, and they get concentrated as you boil it down, it'll be interesting to see what this looks like when we're all done with doing this boiling. Depending on what insolubles form when this is boiled down, because we're removing so much water, we'll then filter it if necessary. We just want a clear solution before we go ahead and distill out the sulfuric acid. Now, when we first distill this, mostly water is going to come over, and you don't want to save that in your final result. So we'll distill this until we see that sulfuric acid is coming over, and we can do that one of two ways. One is by checking the density periodically, or checking the temperature that it's boiling at. But either way you do it, you're going to start with one flask, fill it with mostly water, then you're going to swap it out, and then you'll be filling it mostly with sulfuric acid, more sulfuric acid than water. Okay, no more whiteboard to write on. So let's go make our sulfuric acid using oxalic acid. 300 grams of ferrous sulfate pre-weighed, 200 grams of oxalic acid pre-weighed, 105 grams of ascorbic acid pre-weighed. Before we put the oxalic acid and the ascorbic acid in the main solution of ferrous sulfate, as I said earlier, I'm going to independently dissolve each of these. So I'm going to dissolve the oxalic acid in 400 milliliters of water first, and then we'll do the ascorbic acid. Turning on the magnetic stir, and I am going to apply some low heat to this. 200 grams of oxalic acid going into 400 milliliters of water. All of the oxalic acid has been dissolved, so I'm going to turn off the magnetic stir here. Because I don't want this to come out of solution again, I don't know that it would, but I'm going to put it on a separate hot plate, just keep it warm. Here's the 105 grams of ascorbic acid, and because I want to dissolve this in as little water as possible, I am actually going to add a magnetic stir to it, like so, because that eventually will make its way to the bottom as I add distilled water and slowly dissolve the ascorbic acid. All the ascorbic acid is dissolved. It took the full 250 milliliters to do it, and I did end up heating it up to around 40 degrees Celsius. That has to do more with time. I just didn't want to wait around for this to completely dissolve slowly, to be perfectly honest with you. I don't know if this comes through on the camera, but it's a slight yellow color, very slight, and that's because ascorbic acid does oxidize to dehydroascorbic acid when it's exposed to air and light, which is happening right now and has been for like the last 40 minutes. So I'm going to stop this, cover it up, and put it into a nice dark cabinet until I need it. Now that the other two ingredients are dissolved, we can mix our ferrous sulfate with the 1 liter here. So I'm going to turn on the magnetic stir, and we'll start doing that. All of the ferrous sulfate has dissolved. I did get it up to around 50 degrees Celsius in order to do that, but it's done, and now we can start adding other things to it. Well, I didn't heat this quite enough. That's oxalic acid crystallization in there, which is now breaking down because I started to heat it again. But somewhere around 30 degrees or so Celsius, it did start to come out of solution. Just be aware. I have a nice warm oxalic acid solution here, and we're going to add this now to the ferrous sulfate. This will bring out the iron oxalate and the sulfuric acid. I let these two mix for about 15 minutes just to make sure that everything had a chance to interact well. The iron oxalate that we formed is suspended in solution, but it's being mixed thoroughly, so it almost comes to the surface of the solution because of the mixing. If I stop this, it would all precipitate to the bottom. We need to add the ascorbic acid at this point, but it's too warm. It's around 60 degrees Celsius, so it needs to drop to 30 degrees Celsius or lower, and then we can add our ascorbic acid. Again, that's to convert any iron 3 back to iron 2. So I'll be back when this is cooled down. This is now cooled down to around 25 degrees or so, plenty below 30 degrees Celsius. So I'm going to start adding the ascorbic acid. We do have a nice yellow color. Normally, if you have more of a brown color, you're more worried about the iron 3, but there's definitely some in there. So I'm going to add maybe half of the ascorbic acid, and then maybe save the other half, because as we go, and depending on how long it takes to get to the vacuum filtration, this solution can again form more iron 3. I added about half of the ascorbic acid, just like I said. I'm going to let this mix good for maybe another 15 minutes, and then we'll turn off the magnetic stir and let everything settle out to the bottom, the iron oxalate. 15 minutes are up. I'm going to turn off the magnetic stir, and we'll just let this settle. It's been a full hour since I turned off the magnetic stir. There are still some small particles in solution, obviously, but it's going to take a while, I think, for those to completely fall out. I'll be back when it's done and ready to vacuum filtrate. This ended up sitting overnight, so I covered it with some plastic wrap. You can see how much clearer the solution is now that all of the iron oxalate has settled. Let's go and filter it. I had broken my 1 liter round bottom flask that I usually use for large volumes. So I'm now using these 1 liter volumetric flasks right here. I'm gonna need a couple of them, I think, to complete this, but you can see how tall the necks are, which is why this filter portion is so high up in the air. Just wanted to explain that. All right, turning on the vacuum filtration. Letting all the iron oxalate settle should help this filtration here, because we're just decanting solution off the top. We just finished filtering the first just over a liter of sulfuric acid, very weak, of course, and of course this needs to be boiled down and distilled, but the rest of it I'm not going to bore you with. I will video when I actually start filtering out the iron oxalate. It's about half of what I need to do. I'm going to turn this off because that needs to be obviously emptied, and then I'll continue on, but I'm going to do all that off camera. So the next step, we should have only the liquid sulfuric acid, plus of course there's other things in there, but we'll boil that down. Completely done removing all of the iron oxalate. So I have these two solutions here, both the same thing of course, that I'm going to put back into this large beaker, which I cleaned up really good. I kind of feel like a mad scientist right now. Okay, now we just need to heat that on. Before I turn the heat on here, I briefly want to go over what still might be in this solution. Of course, we have sulfuric acid. That's mainly what we're trying to make here, but there still could be some iron sulfate, some oxalic acid, some iron oxalate. Hopefully we got rid of that when we just filtered it, but there still could be a small amount. Ascorbic acid and dihydroascorbic acid. So quite a few things still. When we are heating this, those will all be concentrated in the final solution. But fortunately, when it's distilled, all of those things won't distill over, so we'll just get the sulfuric acid in the end. Okay, turning on the heat here. Over half the solution has been evaporated. Obviously, that's mostly water. However, we did have a significant color change here, and a lot of what you can see even stuck to the sides of the glass is this brownish black residue. And that residue comes from a number of things, I believe. One of the things I forgot to mention earlier when I was commenting on what was left in the beaker before we heated it was the iron 3 oxalate. We added ascorbic acid, which hopefully got rid of a lot of that, but obviously there was some left. And iron 3 can complex with other things such as air, and it can actually form rust, which is kind of brownish black. There's iron 3 oxalate complexes in there, I believe. There's also carbon residue from the decomposing ascorbic and the dihydroascorbic acid, and that, when it gets heated, turns brown black, kind of like carbon substances do. And there's ferrous sulfate in there, which also can complex with some of the other things I already mentioned because of the heat. So the idea here now is to get our sulfuric acid out of this. So what I'm going to do is let this cool down completely. We'll see what settles out of it. We may have to decant and refilter. That's fine. I let this cool down over the last 6 or 7 hours or so. It was really hot. So over that time, about another 200 milliliters evaporated out of there. Most of all of that was water. Again, we started with 1 liter of water. We added 400 milliliters of water. We added another 125 with the ascorbic acid, etc. So even what's left in here is probably mostly water still. We have about 650 milliliters in here of this pretty brown, black, gnarly looking stuff. But 650 milliliters is larger than any of the flasks I have, so I'm probably going to have to do 2 distillations and maybe divide that into half when I'm actually trying to get the sulfuric acid out of there, which is still in that mess. Believe it or not, it kind of smells like caramel topping. I'm just saying. It does smell like that, like a lot. Just, it's kind of weird. Nothing settled over that 6 or 7 hours, so there's nothing really to decant. You can see stuff floating on the top even. So I need to filter this off camera because I'm not going to bore you with that. You've seen that already a couple times. So it just needs to be cleaned up so that we can distill it properly. When I started working with this, it turned out to be very messy. So I nixed the vacuum filtration and just did gravity filtration. Took a little longer, of course, but I basically scooped everything out of there in here. And down here is what we have to actually distill, and because there are no solids in it, it dropped down to 400 milliliters, which means I can distill this all at one time. Nice. I didn't get to the distillation last night, so this ended up sitting overnight, and if you tilt this just a little bit, you should be able to see up there some crystallization. That is most likely just unreacted ferrous sulfate, no problem, of course, but I'm going to decant off the top, leave the crystals on the bottom, and get the distillation set up. All done. Just a simple distillation setup. I'm sure you've seen this dozens of times. This is my homemade fume hood right there. Down here is where I'll be collecting mostly water at first, then we're going to swap out the flask when we collect the sulfuric acid. Help understand when to change that flask out from, more water to more acid. I took known values of the boiling point of sulfuric acid here at 50, 70, 93, 95, and 98%. There are those values, and then I just graphed them out here. And so here's your percent sulfuric acid down here and the temperature up this way in Celsius. And you can see the closer you get to this 98% sulfuric acid, the extreme rise in this curve right here. Certainly not a linear relationship. So if we come down here, we're probably going to get sulfuric acid somewhere between 65 and 75% sulfuric acid. If we look at 67.5% sulfuric acid and we come up and then we go over, we get around 162 degrees Celsius. And if we look at, what is this, maybe 72 72, 73, 72 degrees or percent sulfuric acid. Come over, we have 170 degrees. So my guess is I'm going to swap that flask out right around 170 degrees. Pouring in the final decanted solution. And plugging the opening, I just poured it in and locking it in with a clip. Turning on the heat here, and I'll be back periodically. Here's the solution. I had to pour it in here because you partially saw what happened where it bubbled and frothed. It ended up going up and over the distillation tube, which of course you don't want. So I poured it back in here and I've cleaned up everything. And what I'm going to try now is this 1 liter volumetric flask. I've never done this before. You saw this earlier, but I got to work with what I got here. So hopefully this will work so that the bubbling and frothing, which is going to occur again, doesn't make it all the way up and over. Everything's set up here, but I only put half of what I had, which is 200 milliliters in here, just to be extra safe. I do not want to do this again, but everything is set up here for take 2. Turning on the heat. As I'm now collecting the sulfuric acid down here, you can clearly see this white vapor, and that is most likely sulfur trioxide that's interacting with the moisture in the air. So one of the big reasons you need to do this under a fume hood, which I am doing, or outdoors. Everything stopped dripping over, of course meaning the sulfuric acid. The sulfur trioxide gas is still in there, but it's dying down as everything cools down here. I did cover it with some saran wrap just to keep the gas trapped in there as long as possible. But when this is completely died down, I will swap it out and we'll start the second distillation. On this end, because everything stopped dripping over, I turned it off, of course. It's still pretty warm and you can barely see that sulfur trioxide gas still kind of gurgling through the top right there. Of course, as it cools down, that will dissipate completely, and that's when I'll take this apart. You can also see that this bubbled up right to the neck there. So I'm grateful I only used half of what I used because this ended up turning out really, really well. It's really remarkable when you look at distillation. You can take a grungy mess like that and turn it into such a clean solution over here. These are the 2 flasks I just used. This is the water here, that's about 140 milliliters, and the acid on this side, which is, I don't know, maybe around 25 to 30 milliliters. So if you add those together, you're going to end up with 160 to 65 milliliters. The reason there's not 200 milliliters there totaled is because of this mess in here. And of course, whatever was left in here didn't make it over, and there's quite a bit of solids that ended up forming. That's going to be a nightmare to clean up. But anyway, so I just wanted to explain the situation here. Everything's been cleaned up and reassembled, all set for take number 2. Turning this on. Because you've seen this already, and I really don't want to bore you, I am only going to put up the video of collecting the acid on the other side. Done collecting mostly water and swapping out the flask now for the more of the sulfuric acid. The sulfuric acid has stopped dripping over, so I'm going to let this calm down again, and I'll disassemble this, and we'll combine both flasks together. I'm going to combine these 2 solutions like I said, and then we're going to test it to see if we have sulfuric acid. So I would say a total of about 60 to 65 milliliters of sulfuric acid. Like I said in the beginning, this is not an economical or even feasible way to make sulfuric acid. It's just for the chemistry. First thing I'm going to do is just test the pH. This will, of course, not give us the most precise pH, but it will tell us if there are protons or hydrogen in the solution. Bring that up here. You know, that's between a 1 and 2. Now, 70% sulfuric acid would give you around a 1. And I would say that's pretty close to 1 right there, actually. So we know we have protons in the solution. This next test I've done quite a bit, actually. So we're going to take some of the sulfuric acid here, put it in this test tube, not much. That should be enough right there. And when you combine sulfuric acid with barium nitrate, you get barium sulfate, which is insoluble and falls out of solution. So we'll do that next. This is confirming the sulfate portion of our sulfuric acid, the SO4 portion. Oh wow, yep, I mean, for sure. We have the sulfate portion plus the protons, meaning it's sulfuric acid plus the chemistry that we just did. To get sulfuric acid, all adds up to sulfuric acid. And when I weighed this, I got about 1.58 grams per deciliter or so at 20 degrees Celsius. It's like 19 in here, but close enough. And that's another reason why you don't do this, to get, around 65 milliliters of sulfuric acid at 67% out of 2 liters of solution that we started, just to drive home the point. Once again, this was just to watch the chemistry, not to actually make a lot of sulfuric acid. Much earlier in the experiment, I pulled out some of that iron oxalate, cleaned it up good because there were a couple solubles in there, but I washed it good with cold water and then dried it up. Just wanted to show you what dried iron oxalate looks like.